Our next speaker is Steve LaValle. He's Vice President and Chief Scientist of VR, AR, MR at Huawei Technologies. He is also a Professor of Computer Science at the University of Illinois at Urbana-Champaign. He's published 3 books and over 150 scientific articles. He's here today to talk about virtual, augmented, and mixed reality. Where is it all going? I hand it over to you, Steve.
Great, thank you very much. Very happy to be here today, and I appreciate the opportunity to speak. I was in Tampere earlier this year, and it's great to be back again. It's a beautiful city, and look forward to meeting people here and having some great discussions. A little bit of background about myself. I was an early founder of Oculus VR, the VR company that led a consumer revolution. And give a little bit of history. It happened very, very fast. The company was founded around July of 2012 by a 19-year-old in California named Palmer Luckey. They had a Kickstarter campaign a month later, and shortly after that ended, I started working for the company, actually from Finland, believe it or not. I'll say something about that in a bit. And then later joined full-time as their chief scientist, and that was around March of 2013. And then the value of the company grew very fast, and it was sold to Facebook, rather famously. People know about this, I think, here, for a couple of billion US dollars. And I then went back. I was on a break from the university, and then I went back to the university after that. And after that time, I've been an angel investor and advisor to companies, also part-time professor. And then a year ago, I joined Huawei as chief scientist for augmented virtual reality, mixed reality, and spend a lot of time working on product, coordinating research, things of that nature. So I mentioned a little bit about Finland. The first thing I got involved with Oculus, they needed to solve the head tracking problem. So when you wear a virtual reality headset and you turn your head, you have to have the images appear the right way so that it cancels off, let's say, the rotation of your head. So that when you turn your head, the world gets adjusted so that it appears to you that the world is remaining in one place. So it's a very critical problem. I was up in Oulu with my wife, that's Anna Yershova. My wife and I were working with a robot with a sensor attached in an apartment up there. And the robot was swinging by a lot, and we were sort of writing code and working on tracking methods for the company. And then eventually I branched into other things. So there's an interesting connection back to Finland for Oculus, which some people may not know about. Probably most do not know about that. Little bit of VR history. Certainly goes back for a very long time, the beginnings of the technology. People very often cite Ivan Sutherland's Sword of Damocles. Interesting videos of that on YouTube you can find. So it was an actual wearable display, but it had a kind of cantilever beam and attachment, so with cables, and it was quite a bit awkward, but quite an interesting demonstration. And the idea was to make the ultimate display. So Ivan Sutherland made that. It was a great big boom of virtual reality in the 1980s. Jaron Lanier was one of the people really pushing the technology at that time, leading in many ways, and popularizing the term virtual reality. There are cave systems, which are systems where the images are projected onto the walls, and you go inside of the cave and you wear some, let's say, fancy glasses like you might have at a 3D movie, but a little bit more technology put in than that. And you get at least a full-size walk-in kind of virtual reality experience, because it took quite a while for the headset technology, the portable technology, to advance. Brent Leonard made the movie Lawnmower Man. He was the director of that. He's still very active in Hollywood and around in the VR community. I served on a panel with him earlier this year in Berlin for the film festival there, and I talked with him quite a bit. There's a lot of interest around Hollywood and beyond. All of the hype kind of came crashing down in the 90s, especially ending with a product called Nintendo Virtual Boy, which was touted as a great VR game system, but you put your head inside of it, and it did not track your head. You just put your head up to it, and there were red lines that draw the environment or the game that you're playing. The rest is a black background. And people got headaches. They were not too impressed, and then this caused the industry to stay away from this technology for a long time. It's still active in universities for a while, but it sort of died in terms of industry. So the problem that these technologies have, virtual and augmented reality and beyond, is that people tend to get very excited about them very quickly. And then when the reality doesn't match the expectations, the actual products do not match the expectations, then it seems like the trend goes back down and a kind of bubble happens. So I'll explain kind of these trends a bit and try to get you an understanding so you can understand perhaps where things are going if you're thinking about doing work in this area, whether it's university research or business, startup companies, or larger companies as well. One of the key problems for the reasons why this technology seems to go up and down is that people get very excited, but the component technology is not mature enough very often. And when the Oculus was founded, the smartphone screen technology and the sensor technology that's in the phones and the computation power, especially graphical computation power, was advanced enough so that you could make a much more impressive and a high-fidelity virtual reality system for only a few hundred US, competing against systems that would have cost hundreds of thousands of dollars just a couple of years before, because all of these commodity components became available because of the smartphone revolution. So that's very interesting. That's the kind of thing that happens. You can recycle the components and make some very impressive things. So 2016 was touted as the great year of the VR consumer revolution. Many companies have interesting products that had come out. There are many more than this. I could go through and list hundreds or thousands of them even. Especially if you spend time in China, you'll notice that every city in China seems to be able to make its own local versions of headsets, and very quite good ones too in many cases. Huawei as well jumped in last year with consumer devices, and there are certainly more things in the works for Huawei, but I can't talk about that, unfortunately. So those are product roadmaps and things, but we certainly have a great interest in this area, of course. The big problem, people talk about this, people like to say it's the killer app problem. Even the phrase killer app reminds you a lot of smartphones, and it might not even be the right kind of phrase, but this is the issue that people worry about, is what's going to be the application, really the thing that people want to do with virtual reality systems that will drive this industry. And it feels a lot like we're maybe in the year 2002 right now, 2003, with regard to smartphones. And it's very hard to predict what these virtual reality headsets might evolve into use cases that we would rely on every day. So if you take applications such as Facebook or Uber, things like that, WeChat in China, for example, these things were very hard to maybe envision as something everyone would carry around with them and use all the time and rely very heavily on. They became enabled by the smartphone ecosystem that gradually grew up. And the same thing's going to happen here. This is an enabling technology, but we have yet to really see what's going to cause everything to, I think, fully cause this industry to explode. Here's some examples. Of course, people thought very carefully about transferring video games into virtual reality so you can step inside of the game. It's had some limited successes, I would say, but it's still not, I would say, that the dominant thing that people want to do on this platform. It has not been successful enough yet. Some of it is because of side effects, such as sickness in VR, which I will talk about a little bit later. There's so much data on the internet, so many things that can be viewed inside of these headsets. So one thing someone did very early on, we noticed this when we made our software source available at Oculus and people started developing. Someone quickly connected it to Google Street View, and you could jump inside of panoramic street views all over the world. And that was fascinating immediately. And it required no extra developers or art department to make virtual worlds. We thought that was really fascinating. And it looks very 3D, even though they're just panoramic photos, which I will also talk about in a bit. Many different applications, and I'll just kind of go through some examples. These are the kinds of things that people will often tout as this will be a big future. And I think it will be, but it's not going to happen overnight. And in the area of virtual prototyping, especially in real estate and home building and design, architecture, these kinds of things, there's a lot of applications of this technology. I think the bottom one is virtual, the upper one is real. I know all over Finland there are companies working very much on this. I know they have a virtual view. I know it's quite standard in Finland to have certainly two-dimensional views that are lifted up to maybe be 2.5-dimensional. People want to give fully immersive experiences for helping in assessing real estate properties and things of that nature. Socialization or hanging out with friends and family in some way still remains to be seen how that's going to work and what's really going to cause a revolution. But I think it's one of the most interesting by far applications of this technology. You can consider it falling under telecommunications, which Finland certainly has a strong and proud history of, and it's a great opportunity, I think, to figure out how to connect people over great distances through this technology. And you can do all kinds of interesting things through avatars, or you can just capture actual images and transmit those. A number of different ways to do things. But when you go into a virtual world with avatars, you can make social interactions that are, let's say, maybe better than normal, better than the usual things that you have. Like, for example, in this speech today, I could be looking at each and every one of you at the same time if you are wearing a virtual reality headset where you have a slightly modified version of the world, right? I'll be looking right at you. It's a great way to terrorize students at the university, right? You make them all think that you're watching them. So many things can be done with this. Has anyone seen these kind of Gartner hype cycles before? So quite common. So a few of you. This is a very popular way to assess where the technologies are going. And these things change very quickly. If you look up at the peak, this is from last year. Maybe that's not too readable. At the peak is machine learning. Right before the very bottom, so this is supposed to be time on the horizontal axis, and then amount of hype on the vertical axis. And it goes up to the peak of inflated expectation, and then goes down to the trough of disillusionment. That's like the bubble bursting. Then you have the slope of enlightenment, and eventually you have this kind of great period of productivity. And augmented reality is just about hitting the bottom there. And then virtual reality is the last one on the plot, and that is coming out to the great land there. Now that was done in around July of last year, and in the very same month, this happened, right? Which all of you have certainly heard about. It's incredible to see the amount of enthusiasm around Pokemon Go. It was quite a surprise to everyone, and this caused all of the big companies to respond in some way. But everyone's, let's say, arguing about what exactly happened. So some people will tell you. In fact, most people will probably say the bottom one. This was a great augmented reality phenomenon. Everyone's excited about augmented reality. We knew it. This is going to be the great future. And that's caused a lot of companies to invest heavily in this over the last 12 to 14 months. However, maybe it was just a Pokemon phenomenon. Maybe it was just a geolocation game phenomenon, right? And the graphics, the way that the Pokemons appeared, the stability of them, maybe was not too critical to the experience. So people are debating this quite a bit. And this is a kind of augmented reality that involves holding a smartphone out and just looking through it rather than wearing it. So in some sense, that lowers the bar of requirements for some kind of different reality. If you can hold it up with a device you already have and just look through it, then this seems a lot easier than trying to build some futuristic kind of eyewear, right? So people got very excited about that. That changed everything. So that now, when you see people making projections of the future, rather than augmented reality crashing down, you see a lot of this for investment predictions and things of this nature. These kinds of slides are typically made to help venture capitalists and startup companies, other major companies as well, tend to use these things. And so this was something that came out a couple of months ago, and you can see it's very heavily influenced by, I think, the Pokemon Go wave and a big rising interest in augmented reality. Apple has jumped in with AR Core, which runs on their iPhone platform for developers to make AR apps very easily. And Google has released something similar for Android a couple of weeks ago. AR Kit for Apple, and it's AR Core for Google. I think I got the names mixed up a bit. So the phase that we're at right now is this mobile AR software, where you get software, these kind of developer tools or kits that run on your phone, and you can do Pokemon Go-like things and a few more advanced things than that. And then people expect the hardware to advance after that, let's say in a year or so. And so that you can have specialized sensors that scan the world around the phone and can provide even more data so that you can superimpose the kind of virtual objects that you make, like a Pokemon or other things that you make, with the real world and have them align very, very well and have very kind of accurate representations. Then it's believed that people will go to tethered smart glasses. So maybe we'll have some kind of beginnings of eyewear that's lightweight, stylish, comfortable, but it connects to your smartphone as a kind of computation base. So you still have a computer in your pocket, let's say. Is it connected with a wire or wireless? Remains to be seen. I think it will start off maybe with a wire and then go to wireless. We'll have to see. Eventually, we'd like to have the standalone, all-in-one, really cool glasses that do everything that your smartphone does now and a bunch more. Would it replace the smartphone? Probably not. It may be something that's different, just serves different kinds of functions and features, but it remains to be seen. So that's a kind of projection based on this dramatic event last summer, for sure. It has helped reshape the way many companies are considered. We were happy to see Huawei on this projection as well from DigiCapital. So as far as the terminology goes, I've been talking about augmented virtual reality. You may wonder about these things a bit. So the term virtual reality can be traced back to Immanuel Kant, the philosopher. And at that point, he was not talking about some kind of technology, but certainly these kind of alterations in the brain and the way of thinking about a different kind of reality other than the physical one that we normally experience, how it might be altered in some way. And Jaron Lanier, let's say, kind of hijacked the term for technologists and said, this is what the technology is, virtual reality. Then, especially in the U.S., with academic research, as one trend goes down, people say, wow, the new thing is augmented reality, not virtual. And they make a distinction with that, and augmented becomes adding bits of graphics to the real world. And being able to, you may have a see-through display, like some kind of glasses you can see through, and I may, for example, make all of your names appear above your heads. So that at a conference it could be very convenient. You don't know if I remember who you are or if I'm just cheating, right? We all face that problem at a conference. So it could be like, oh, that's why we have name tags, but then they get flipped around backwards, all these kind of problems. Let's see. Then there's mixed reality, which was designed to kind of cover the whole spectrum between augmented reality and virtual reality, where virtual reality was, I would say, a kind of purely graphical world. As I will explain, these boundaries have become very fuzzy in modern times, but especially as I look at things like Oculus, Facebook VR. There's a demonstration there that was made recently by Mark Zuckerberg, and this has a couple of floating heads socializing inside of a panoramic background. Microsoft HoloLens AR, or mixed reality, they like to use that term a lot. That's very clearly an AR kind of headset. Oculus is supposed to be a VR kind of headset, but people are doing very similar kinds of things in these. And real-world images and virtual graphical images are getting mixed all the time now, especially because everyone's carrying cameras around in their pockets. So it's so easy to get real-world data. So that trend has been increasing quite a bit. So these things are blurring quite a bit as far as the boundaries go. Oh yeah, I have one of these neat little gadgets. As far as where the terms are going, it keeps evolving and everyone's trying to get out in front as the terms change. Lately in Silicon Valley, over the past year, I've heard the term XR, where X is trying to catch everything. In my personal opinion, I thought virtual reality was already general enough to cover it all. I'm happy with Immanuel Kant; it's okay, you know. But they keep making up new terms. I decided to have a little fun with it for this discussion. If you have a computer science background, or if you're accustomed to old like DOS directory or Linux directory listings, maybe we can just call it asterisk R, and you can just fill in anything you want for asterisk, and it's just all different kinds of realities. Again, I consider them all to be virtual if technology has been used. People in industry would really like to figure out when they're going to make money in this area. So maybe they might want to call it $R, or thanks to the rising strong euro, you may want to call it this here. So it's doing very well lately, I've noticed. So, but that's really the key: is how are we going to have a whole ecosystem where companies are making great profit off of this? Still remains to be seen, regardless of what letters you use to describe it. So that's what I'm saying here. What's really needed for some kind of success? So for this, I want to say there are three main pieces, and I'll call them the 3 E's of product success that I think the companies either are focusing on or should be focusing on. We're certainly interested in solving these in Huawei. 1 is ergonomics, 2 is ecosystem, and 3 is the engineering. Very often companies focus only on the last one, and they get distracted by that without building up everything together, and then you have a sort of a failed business, let's say. So the ultimate display, what is the ultimate goal? There's a picture of this Ivan Sutherland first headset. Actually, we would call it in today's terms augmented reality, but it was always cited as the example of virtual reality because, again, the terminology keeps drifting and as people compete for resources in companies and universities. You see the Oculus headset that came out in 2014, Microsoft HoloLens, and maybe you've heard about or seen these Snap spectacles, very low-cost device that just allows you to snap photographs as you walk around. Google Glass tried that 5 or 6 years ago, let's say, and it was considered a failure because of privacy concerns. But the current generation of millennials can wear these glasses around, and people seem to not be bothered by that, even though they're taking photos. Some lights appear whenever the camera's on and ready to go, and it is video recording. So it at least alerts people that it's happening. So it looks like socially things are becoming acceptable and perhaps settling around some kind of stylish glasses that can maybe ultimately project some kind of images onto your eyes, and you don't feel like you're wearing some cumbersome, heavy thing. So what's the ergonomics? So the thing that people have realized is, for the ergonomic side, is we must have this device be light and stylish. We want to ideally not have wires hanging from it, so wireless streaming, cloud connections, all these kind of things are critical. So that's great for people who care about that kind of infrastructure. We'd like to see a world where higher and higher sort of fidelity and resolution kinds of content is coming along. We'd like it so you could possibly wear it all day without, falling into a ditch because you're not paying attention. Right? Imagine you can do your texting very nicely in a hands-free way and see-through way, which is small text messages appearing, with a lot of privacy, by the way. I've noticed, I lived in China this summer in Shenzhen at the Huawei headquarters, and I've noticed that people on the subways there very densely packed in, and everybody is texting on WeChat. About 80% of the people standing there in WeChat. It's very easy to just look around and see what everybody's doing. I cannot read Chinese, so it's fine for privacy. You don't know what I don't see anything. But I thought, wouldn't it be nice if people just can do those things with some kind of very private glasses? And I think as we approach this technology, we should strongly focus on the ergonomics and not try to make these glasses do everything. Because when you try to make them do everything, then they get heavy and expensive, and all of a sudden you have a bad product. So we need to focus on the kind of lightness. I think the Snap glasses are a very nice example of just picking one thing and making the device light and low cost and comfortable. And the one thing in that case was just taking photographs and then transmitting them to your phone for sharing. So that gives you an idea. We want to have, to focus in this way on the ergonomics. The ecosystem, also very important. Each company has its own reasons for focusing on some part of the ecosystem. If it's a video game company, then they're going to focus on gaming, and they're going to assume that it's a natural adaptation of that. If it's a movie company, if it's Hollywood and related video and media companies, they're going to like a lot interactive story worlds and panoramic videos. And in the smartphone ecosystem, there's a lot of interest in camera filters, making your camera more powerful on your smartphone. Again, I mentioned some other examples, architecture, social. And so the strategies are, this is very interesting. There's a shadow here, and in the periphery, it looks like that's the rest of the stage. So I may take a plunge at some point, and you'll have some entertainment. So I need to be very careful. The strategies that you see is companies are very often what I would call recycling content in the way they invest, or there's some cases where radical new artistry or artists are doing things with these technologies that are quite unexpected, and they don't necessarily lead directly to a business model. But I feel like it's a lot like the experimentation of the early days of film. Going back to, say, 1900, right, over 100 years ago, nearly 120 years ago, it was just artists making films. And they would surprise people and shock people. The train pulling into the station is a famous one from France back at that time. So that's really where a lot of excitement is happening, but it's going to be a long path towards, let's say, profitability and large industry. Another strategy is you just give developers a software kit to play with. We did that at Oculus. We see that happening with Apple and Google and so forth. You just let them play around and hope they make something good that will grow the overall business. So that's about ecosystem building. Again, the problem, I've said this before, I think, is everyone is recycling. So people recycle what they already have, what they already know. If you have some expertise and you want to jump into this area, it seems very natural to just apply what you know. But the way all of these things work, it ends up being quite surprising to people that what was a good experience or product in one domain does not work at all in virtual and augmented reality. So that's caused a lot of surprises. So people recycle the hardware components, the software, could be game engines, graphic techniques. And there's a big blind spot, which I will get to near the end of my talk, is human perception and physiology. The human side is being largely neglected or certainly not given as much importance as it needs to have. So we need to really take these things seriously. I was using the XR here to just kind of unify some things somewhat, but we need to take all of these pieces together in a holistic way, actually, instead of decomposing and recycling, and try to develop a whole new engineering philosophy, a whole new system for doing things, and that will take quite a bit of time. So with this kind of recycling philosophy comes a kind of micro bubbles, where each time you have a component that you recycle, you make some progress very fast, but then it doesn't really work well enough, and then people get disappointed. So they get excited, they have a nice demo, and then there's disappointment. These are the things we see over and over again in this technology. All right, so the main engineering challenges that companies face, the displays and rendering is really the hardest problem right now. We have recycled smartphone screens, but we need them to be much higher resolution, and they need to solve a bunch of other problems, which I will mention in a bit. Let's see. The interaction problem, how we interact with these devices, very important. For the computer, it was the keyboard and mouse. For the smartphone, it's these two-fingered kind of manipulation we can do on a touch screen. So what exactly is going to be that? These have to be figured out, and also how to distribute communication and computation. So I've talked about the ecosystem and the ergonomics overall, and we have to solve these kinds of problems in engineering in order to enhance those. There's many things that have to come together here. For example, just a simple problem such as reading text. is virtually impossible in VR unless the text is enormous. You can read text on your smartphone, that's what it was designed for, but you cannot do that very well in VR yet. Interesting startup company in Helsinki called Varjo is making a lot of news because they have a very high-resolution display within the place where you're looking. And I was out there a couple of days ago, got to try it out, and yeah, you can read text on that. It's very nice. It will take some time before these things come into the mainstream market or the consumer market, but these are very important kinds of things that all come together to make the economics and ecosystem. Engineering has to follow along with this and deliver the kinds of things. All this has to happen together, let's say. I should not say maybe follow, but it all needs to happen together in a coherent way. So the core technologies, there's a kind of virtual world or augmented world, whatever you want, some kind of generator here. There's input from sensors, there's output to displays, and then there's this interaction. So that's just one kind of not hierarchical, but a block diagram-based view of that, of what I just said. Problems are resolutions of displays are not enough. The resolution of displays on the smartphones you're almost all carrying, and on your television sets, especially if you have a 4K display, are high enough so that you do not see pixels. But if you put a magnifying glass in front of a display, which is the way that the current virtual reality headsets are made, then you can see pixels, which makes the display makers very excited if this market becomes big because they can sell more and more displays and keep advancing their technology. But right now it's about 1/4 as dense as it needs to be along each dimension. So we need to have a lot better advances. There's also problems, things such as vergence, accommodation, mismatch. I won't have time to go into the details of that, but it's very similar to the problem of what happens in a movie theater. When you watch a 3D movie and something appears in your lap, it's always in focus, even if it's very close to your face, which is a kind of strange problem. In other words, if you closed one eye and looked at it, it would seem like it's infinitely far away, but they're just doing the eye convergence part of stereo to make it 3D, but they're not handling the eye focus part. And so for people under 50 years old, or so say well under 50 years old, that mismatch becomes a problem. As you get older and need reading glasses, then it doesn't matter anymore. So there's some interesting kinds of issues there. And if you don't solve these, it may lead to extra fatigue and headaches and problems for people. Someone have a time counter? I'm losing track of time. 15 minutes? Excellent. That's Miko, right? Great. Thank you. So the tracking problem I mentioned, people have to track the world around them. And the reason why is because you want to bring, you either want to keep track of where you are going. So if I were to make a virtual world here on this stage, and I don't see anybody then, if I want to walk around and have virtual objects appear, then I need to track exactly where I'm going. So that's a very important problem. I also need to make sure that these objects are somehow alerted to me, right? That I know that this is here somehow so I do not trip and fall, or certainly not walk off the edge of the stage. If you have augmented reality, or the full mixed reality, then you want to capture everything that's here. So I may want to capture this very nice and complicated plant, which has a lot of structure to it when I look at it from every different direction, and it flops around. It's going to be almost impossible to just capture all of that graphically and send it and completely re-render it. If you have a kind of display where it's like glasses, maybe you just look straight through and it's fine. And then you just have extra information appearing. I could make some extra flowers appear there and whatever else I like to change it gradually. So this tracking becomes very important, to track the world around you, to build maps of it, to track it as it moves. These kinds of things are very crucial to the technology. The other part, as I mentioned, is interaction. What's going to replace the computer mouse? So all the companies now seem to be producing devices that you hold in your hands and you move around like this. Like maybe you have a virtual gun or you have a virtual bow and arrow. This leads to something that people in university research know as Guerrilla Arms. You hold your arms out for too long and you get very tired, right? It's an old way to torture grade school students, right? You hold a book out at arm's length for a long time or something. I've heard about those. I've never actually been tortured like that, but it's a kind of torture. It may be nice for a 5-minute demo when you get very excited, but for something to do for a long time, it's not quite right. So I'm fascinated by the PC mouse, and that was the key that led Steve Jobs to build up the Apple Corporation, right, when he found the mouse at Xerox PARC back in the 70s. And that was developed over a couple of decades of research. And, it's very easy to learn that these simple motions that you do can correspond to what feels like a virtual finger moving around on a big screen. And you learn it very quickly and get accustomed to that. I want to find things like that in VR that, involve maybe very simple, very comfortable motions, relaxing kinds of motions, but my virtual body is doing the right things. And I just learned that association. So that's a critical problem here. I feel like the companies haven't gone far enough on that yet, but there's great opportunities here for this to figure out what's the kind of equivalent of the mouse. It may not be just one device. It could depend on these killer apps or use cases, which we're still not completely sure of. But there were some use cases when the PC was coming around, and eventually the ability to use the mouse made it easy for people to do spreadsheets and word processing and so forth and so on, right? So it really, and certainly drawing programs in CAD, computer-aided design or drafting. So these things came along. So I want to see something like the VR 3D version of that exploits the power of the mind and lets you do things very comfortably for a long period of time, so that when your virtual body can do all of these wonderful things, you will want to stay there, maybe, and not come out to the real world. Well, you should come out for good exercise and diet and things like that, and hopefully have a good balanced life. But nevertheless, I think there's some great possibilities here with this getting the interaction mechanisms right. In terms of computation, it's a little bit small and hard to read, but if you have some computer engineering background, it's like a cache hierarchy. I think that there's a great challenge in terms of where to distribute the computation that goes on for these things. So imagine you have the glasses of the future. So there can be a small computer chip in there, let's say, with a display and a wireless connection or a wired connection, whatever you have in the future, some kind of connection. So something's going on there, but you want it to be lightweight, low power, small, cheap. And then maybe in your pocket, like you have something like a smartphone, it can do more, costs more perhaps, not sure, but it could cost the same, but at least it can do more. So you communicate with that. Then you may have a local base, maybe very much like your Wi-Fi base station, but it could also be a powerful computer as well that does a bunch of computation, like a powerful graphics or gaming PC. And then you could have a cloud services, some massive server somewhere in another part of the world also delivering. And when you go up and down in this hierarchy or directly communicate between different parts of it, there are issues of network, bandwidth, latency, and reliability. And these become critical to solve at different levels. So these still have to be resolved, and companies are thinking about all different strategies. Huawei, being fundamentally a telecommunications company in addition to a smartphone company, is quite excited about solving these kinds of things for sure, and providing very high bandwidth, low latency, high reliability connections at different levels here. Certainly people in Finland have a long history with a lot of experts around here working on these kinds of problems as well. Some in Huawei and some not. So I guess I just explained what's there in words, but so there's these different levels, as I just said, and this is a very important part of the engineering problem to solve these four levels of computation. One of the hardest problems that happens, I call it premature modularization, which is, everyone, this happens in companies, happens in universities, but it's part of this recycling. To really do well in this, you have to have a complete vertical integration. You have to put everything together and have it all optimized together, not just each person works on their part and then we put it together at the end. And that's the hard problem to avoid. And this is going to be really challenging in this space, because we need some very new kinds of display technologies, sensing technologies, communication technologies, software, all kinds of things have to come together, and it's very hard to tightly integrate all of that. So that's one of the biggest challenges or pitfalls that may happen. Here's a term I'll throw out that I like, called perception engineering. I feel like, rather than just calling it asterisk R or whatever comes next, I think what we're doing is engineering a perceptual experience. Perception engineering is the design, development, and deliverance of perceptual experiences. So they somehow tightly integrate with the human senses, be it sight or sound and so forth. Could be touch or anything else you like, but those are the main two, sight and sound. And so I'm referring to human perception here being critical. And I view it very much like if you look at sciences like physics, the engineering versions are civil engineering, mechanical, electrical. Chemistry as a science goes to chemical engineering. Biology goes to bioengineering. So right now, psychology, neuroscience, perception science, these are sciences. I think they need to transform, hopefully through our universities and industry together, collaborating into a kind of perception engineering, right? It's the applied version. It's a version that's tempered and shaped by the demands of society, by the business opportunities, all of these things coming together. And we can make this into a great kind of engineering field. But in doing that, we have to take the human psychology and human perception part very seriously. And I like to draw this kind of picture, and I like to say that the human is the part that you have to reverse engineer. So engineers are accustomed to building up the software and hardware together systematically, or maybe separately, and then putting them together systematically. And there's still the human hardware, which is the neuroscience, and the human, let's say, software, which is the brain and psychology and perception. And these parts have to be reverse engineered because we did not build these. So we need to work with scientists on that. And scientists in those areas have an opportunity to adapt what they know and apply it directly into engineering companies. To give some examples of this, I gave a keynote in Munich a couple of years ago at a conference where everyone was applying VR to animals, to non-humans. I thought this was fascinating. I didn't realize this even happened. So they have, for example, a mouse running on a spherical ball, and they measure the output of different neurons in their brains, and then they present to them a big screen TV, let's say, panoramic view, and they can give them different mazes to run through. And they study the structures that form in their brain. And it's been established that structures such as place cells and grid cells, which each led to Nobel Prizes in terms of for their discoveries, actually get formed in virtual environments like this. So I thought that was really fascinating. And it also made it clear to me who's the scientist and who's the laboratory rat, right, in these cases, right? It's very clear in the previous case, there's the rat and the scientist. In the case of engineering and making these kind of systems, the scientist and the rat are kind of together, let's say, right? They put on the headset, they try it, they put it down, they write some more software, they go back and forth like this, and it kind of mixes everything together. And then they become convinced that they've made something great, but they're really not separating themselves enough from the process. And so you really have to be careful of this and study all of these structures and understand what's happening. For example, this is a very 3D picture, and it does not involve stereoscopic viewing. There are a lot of cues that your brain uses to infer three-dimensional information here. These kinds of things have to be taken into account when you're making displays, when you're making content, so forth and so on. Even perception of motion is very strange. I'm not sure if the screen is large enough. Does that look like it's moving to anyone? Right? If you look at one part in particular, you'll see that it's not. But in the periphery, it feels like it's always breathing or moving. So the human vision system is fascinating and strange. You can look for this as like a fractal optical illusion. If you do a Google search for that, you can find a nice large image of that. I'm sure it was found by accident, this strange motion characteristic properties of that. So when you get into VR development, you have to kind of, let's say, train the rats or the engineers. I didn't just call engineers rats today. Well, anyway, you have to train them to notice the flaws. Otherwise, they'll adapt to what they're making and just think it's great. And maybe this is a problem in many, many disciplines, but it becomes very critical in these kinds of systems. So you have to perceptually train people. For example, you have to perceptually train people. And I'm probably running out of time. I'll just say a little bit more here, and then I can take questions if there's time. One of the things to pay attention to on this perception that ends up being kind of surprising is that the headsets keep getting better, okay, in terms of resolution, field of view, so forth and so on. I've heard some industry leaders say that our headset is so good that the famous sickness problem has been beaten. And what I like to say is your headset is so good that it can make people more sick than ever before. Right? So it's kind of surprising, but as the fidelity, accuracy, all of these things gets greater, you can make people more sick. And the reason why is one of the strongest reasons why this happens is because of mismatch motion. So a lot of people will play a virtual reality experience and grab a controller and move their virtual body while their real body is not moving. So you're just sitting in a chair, moving along like this. And this causes a mismatch. So your vestibular organ knows that you're not moving, but your eyes tell you that you are moving. Maybe you've seen this before. If you sit at the train station and your train is not moving, you're sitting in a car and you look out the window, maybe you're not paying attention. If the train next to you starts moving forward, did you ever feel like you're moving backwards? Right? Just for a little bit. So that's the process called vection. And when you feel this, maybe it's a little bit disorienting, but quickly you realize. In virtual reality, you're doing it over and over and over again when you grab these controllers. So you have to educate developers on that. It's a very difficult problem. People do not take this seriously enough. And even just perceiving something as being stationary. If I have an object out and I turn my head back and forth and I need to have this object be perceived as being stationary. The real world, it's very easy to do. And my eyes even counter-rotate to match the rotation of my head. These things are automatic. You cannot even stop this process. It bypasses your brain. It goes directly from the vestibular organ to the eye muscles. The only way I can stop my eyes from rotating is to put my finger here and stop my eye. So you cannot think about it and stop that process from happening. It's very interesting. So all of these things have to work together. Just making an object appear to be stationary requires all of the engineering system to work very, very well. The displays, the tracking systems, latency has to be dropped to effectively zero. So many things have to happen. I'm going to skip this a bit. I have a sense I'm running out of time. One last slide here. I'll say, at the University of Illinois, after Oculus, I came back and my wife and I started a course on virtual reality that's very, very popular with students. We have 200 students per semester, but we could have 1,000. It's just we're drowning in the success of the class. And it strongly mixes human perception and engineering together. And I wrote a free book. It'll be published next year by Cambridge Press, but it's also free online. I always believe in giving away things that I write. And I also even gave free lectures at India 2 years ago at IIT Madras in Chennai. And that's a system called NPTEL. It was funded by the government. So you can find free videos, too, of me lecturing about all of these kinds of things and more. It's less of the business side or company side. It's more of the fundamental technology and fundamental science that all needs to come together to solve these kinds of problems. Thank you.